Ahoy! So before we get to the meat of today's video, a quick recap of how we got here. So a while ago I made a bunch of batteryless human-powered laser guns, and the idea stemmed from the fact that I thought that in order to fire any gun, you should be able to prove that you're angry enough by shouting at it or shaking it really hard. And the idea of converting that angry energy into a shot is where these were born. Now I made a few of them, but this is my favorite, the underlever cowboy rifle. And when you crank the underlever, that actually generates enough power for a single laser shot, which gets shot out the front. Now, I had no idea what I was doing back then, and honestly, I'm not much smarter now, which is what this video is about. But I had a goal, right? I knew that I wanted to shoot a laser out the front, so I need a laser diode. Also knew that I wasn't going to be generating that much power, so this had to be generally low power. So this is between 3 and 5 volts. Now, I also knew that I needed to generate power somehow, so for most cases, a motor is kind of what you're looking for. And in this case, I used a geared stepper motor, which I simply put as the hinge. So when you crank this, you just be cranking the axle. The thing is, this generates AC voltage, and that's a DC diode. So to convert AC to DC, you need a full bridge rectifier. Many fans rejoice. Now the thing is, you also need somewhere to store that power. So I shoved a 16 volt capacitor in between. And now that's almost there. The thing is, you don't want it to go off immediately. It's only when you press a button or this tiny switch, which is when you pull this, it shoots this thing forward and hits the switch. So you're kind of almost there. The thing is, this is a 5 volt diode and that's a 16 volt capacitor. If you generate way more power by just cranking this to your heart's content or just like really fast or something, something's going to blow up. So in order to control the voltage, I needed a way to take up to 16 volts down to, say, 5. So I looked it up online, and there's these things called buck boost converters, and they can either take a voltage up or a voltage down. The problem is there wasn't enough power inside this capacitor to make it through here alive and come out. This was just, there were so many losses in here that it died before it got out, so I needed an alternative. Turns out there's these things called xenodiodes, or xenodiodes. So how this kind of works, my understanding is, if this is rated at 5 volts, it will allow 5 volts across here, but anything over 5 volts, it will take down this path. So if this had 6 volts in it, and you press that button, 5 volts would go here, and 1 volt would come down here, thereby saving your diode. And back when I was still in overkill mode, I had larger capacitors, larger motor, and there was quite a lot of voltage coming through here. So I put a little piezoelectric speaker in here, those little speakers you get, the flat ones in gift cards and stuff. So the excess voltage would actually go through it. So when you shot it, it actually made a little pew sound, which is kind of cool. The problem is, up until this point, my scientific method of testing stepper motors was to simply connect it up the circuit and spin this with my fingers at what I figured was the same speed. Problem is, all the stepper motors I have been torn out of things I found in the trash along the side of the road, fax machines, printers, 3D printers. Yeah, so I have no specs for a whole bunch of them. I looked them up, but I don't understand what factors affect how much power you get out of it. I found one which is this big, but doesn't generate as much power as this one. But this one has a tiny gearbox in, so speed seems to be important. The thing is, I had no idea. And I needed some concrete way to figure this all out. Presenting the TESTINATOR. So, aside from being a piece of junk made out of literal pieces of junk, it only really has one purpose, and that is to be repeatable. The idea being that you take the stepper motor that you want to test, and you just put it here and connect it to this coupler. Then you come over to the software, and I've made a database of some stepper motors that I have, and you can select it from a list, and that then it shows you the details of that stepper motor, if it has them. Then you select the capacitor you want to use. In this case, I'm using a pretty beefy one. Then target voltage. Like I said, the laser diode I showed you earlier is 5 volts, so we only really want to reach that. The starting period is the delay between rotations, so it determines how fast it's going to be spinning. This will decrease over time. I'll show you what I mean now. So in theory, once you click Start Test, what happens is the Arduino starts spinning this at that specified speed. That turns this stepper motor, which generates power, which then gets rectified and converted into DC and stored in this capacitor. The whole time this is happening, the Arduino is reading the voltage in this capacitor with its voltage divider. That means that we can now read a voltage higher than 5 volts without frying the Arduino. So this could go up to 12 volts or whatever. How this works is it will keep on spinning the stepper motor while the voltage in this capacitor is going up. Going up. So that it will charge, but once it's reached a point where there's no more gains, it will then stop this. It will close a relay, which then connects the capacitor to this resistor. That's to drain the capacitor back to 0, which was read again through here. So it clears the capacitor for the next test. Then what it does is it decreases the time between rotations so that it will spin a little bit faster and go through the whole process again. So let's see that in action. Now this is a low power Bluetooth module, Arduino, the Arduino 33 BLE. So I thought it'd be fun to try something with Bluetooth instead of Wi-Fi. I was wrong, more on that later. So you pair to it, and now this is going to make a little bit of noise, so I'll just breathe heavily in the background while this does this thing. Let's click start. Alright, well, we reached that pretty quickly. So, what did we actually reach? We reached 5.1 volts after almost 5 seconds. And, yeah, at a speed of 0.0038. So, the whole idea is that I would then, these results get stored in the database along with the details of that are known about the stepper motors. And then, hopefully, I can learn from hands-on experience and correlating and figure out what factors affect the amount of power I get, and then try to figure out the correct stepper motor for the job that I'm looking for. Now that's the theory. Unfortunately, if I run this again, we'll see quite drastically different results. Okay, so yeah, that time it took quite a lot longer, and the delay between turns is quite a lot lower. So, while its sole purpose is to be repeatable, it really isn't, and I've got to try to figure out why that is. However, it is a starting point for me to learn stuff, because there's a bunch of things like capacitors. I know how to make one from scratch. There's lots of information about that. But when you try to ask the internet, what happens when I spin a stepper motor? How long will it take to blow up a capacitor? Surprise, surprise, there aren't many obvious answers to that. Because I figured, if I'm spinning this, the capacitor has to constantly get more energy, right? Energy goes from here and goes to there. So I figured that spinning this too much would then, like, at the same speed, keeping rotating, it would blow this up. So if I was spinning this and 5 volts was coming out, that this would eventually overcharge and explode. Turns out that is not the case. If this is putting 5 volts out, and you just keep spinning at 5 volts. You can spin at 5 volts for the rest of your life. This will never get above 5 volts. So that means that the rest of the power is going to heat or something. So yeah, while this is maybe a dumb task and people can comment in the comment section below, stutter, I'm learning stuff already. I mean, I had to learn how to use BLE in browsers. That is not fun. I thought it would be so much easier than Wi-Fi and blah. It's not that great. It's got some nice things where it like does notifications and things like that, but the compatibility across browsers, blah. Also, it's always fun building stuff, throwing things together. I mean, this is a PlayStation 3 PSU from like the old fat model. It gives me the 5 volts I need down here. It gives me 12 volts over here. The stepper motor, which I've never used before, takes between 20 and 48 volts or something, so I just double it up with this voltage doubler. So yeah, it's just an excuse to learn things. So, I mean, if this never works, so be it. But I thought it was fun to share anyway. Hopefully you enjoyed this, and regardless, stay safe. Bye.